employees needed to access. You might have SAML set up, but it's a little easier today with companies like Okta, but it's still not great. SAML is not fun, in case you've ever had to deal with that giant pile of XML. Mobile app login, like I said, this is when the iPhone was first released, so mobile was not figured out. It was even not clear that mobile was going to be important at that point, the way that Apple thought it was going to be, and others. But if you look at articles back then, there were an equal number of kind of dissenting articles, like who's going to pay $400 for a 4-inch screen and try to browse around on that thing. By the way, my HTC slider had Windows Mobile, which at that time was just Windows jammed into a 4-inch screen, and it had a little stylus, and you do like file, open. It was not fun. But what started to happen is sites wanted to start exchanging data with each other. So this idea of delegated authorization started to kind of bubble up. It was not a solved problem, but we had these silos. We had, your Facebook and your Gmail over here, and we had your Yelp and your Amazon over here, and they started to want to swap data with each other. So this is the first attempt at this. Spoiler alert here, the punchline is don't do this. This is what we now know as the password anti-pattern. So you'd go to a site like Yelp, hot new kid on the block, wanted to allow you to post restaurant recommendations and reviews and to see recommendations. And maybe you wanted to invite your friends and figure out where you're going to go to dinner. So this is what you had to do. You pick the mail service of your choice, and then you put in your email address and password for that service. Now, what started to emerge is this was a sledgehammer with a finishing nail. This was really what I want to express here is I want to give Yelp access to my contacts and read-only access, and I want to have control over it and be able to revoke it. At the time, this is the best that we could do. And this gives Yelp the keys to the kingdom, right? Like now that I've given Yelp my password, they can masquerade as me. They can send emails as me. They can look at my Google Docs. They could change my password. Now, of course, Yelp and Facebook and others swore that they wouldn't. In fact, Facebook, this form was still there until 2010. Facebook promised not to store your password. Maybe they did and maybe they didn't, but other sites definitely did. We know based on leaks and breaches and hacks and everything since 2007 forward. So this is really too much. This is too much authority, but it was the best that we could do at the time. So the question was, how can I let a website access my data without giving it my password? And this is shorthand for how can I let a website access my data read only in a way that I can revoke at any given time, that I still retain control of my data. What emerged out of this conversation is what we now call OAuth. It's a standard. It's at 2.0. My friend and colleague, Aaron Parecki, you may or may not have heard of him. He, and a bunch of other people are working on 2.1. And the spoiler alert for OAuth 2.1 is that all it really does, it doesn't add anything new. It removes some of the problems with OAuth that we're going to be talking about today. So everything that we're talking about today, if you conform to OAuth 2.1, you won't have these problems. But there's a lot of confusion around OAuth. If you ever search for OAuth, if you've ever tried to find out information or you're new to OAuth, you tend to get one of two types of results. One is a lot of terminology and jargon. You might even find your way over to the spec. Specs are not fun for your average garden variety developer like myself who just wants to implement something or integrate with something. Specs are very formal documents. They're not great learning tools. There's also a lot of incorrect advice. Now, this is less, fortunately, now, but even as of a couple of years ago, prominent companies or bloggers would say, use OAuth this way, and it was just wrong. It's also hard to find a lifelike example. The other type of result that you get tends to be deep dives into code, which is great. If I'm a Java developer and I see how to integrate with OAuth Spring Boot example, I can, kind of mimic that, but I don't really have a deep understanding of what's going on. So we want to strike a balance here. Maybe you don't need to be an expert in OAuth, but you want to have an understanding of what's happening behind the scenes so you can avoid some of these pitfalls. So let's see if we can bring in a real life analogy here that'll help us understand OAuth a little better. This is the hotel analogy. It's good to be back out in person and using hotels again. I don't know about you all, that's the way I feel. But in how we interact with hotels, as it turns out, maps onto OAuth in some pretty useful ways. So here are actors. We have the guest, the hotel, the receptionist, the room at the hotel, and we follow a pretty standard flow to interact with our hotel. I go and book a room. I obtain a key from the receptionist, and I can then open that room. Pretty straightforward. But there are some elements of this interaction that map onto OAuth in some pretty important ways. So the first one is expiration. Now, we don't maybe think of it in those terms with hotels, but the key that I've obtained, if I have a one-night stay in a hotel and I leave the next day and I hang on to that key, if I come back, I can no longer open that door because the key is expired, and the manager or the receptionist didn't have to like set a reminder and go and revoke the key. It's automatic. It's built into the key. Well, we're going to see in a little bit that we trade in keys with OAuth. Instead of a hotel key, it's called an access token, but that also has a built-in expiration. The other thing is, or another thing is scope. Again, in the context of hotels, we don't really think of scope. That's kind of a term we encounter in computer science a lot. But if you think about it, your hotel key wouldn't be very secure if it opened all the doors on your floor. It opens your door. It's scoped to that door. When we talk about access tokens with OAuth, there's a built-in scope to that access token, and it might be something like read-only access. And so then if Yelp tries to use that access token to say write to my contacts, it's going to fail because the Google Contacts API can interrogate that scope and knows that the operation that's being attempted is out of scope. So my hotel room key can only open my door. An access token can only be used in the context of the scopes that's been allowed. Now, the last thing is where we get into a real subtlety of OAuth, and it works well with the hotel analogy, and that is OAuth is concerned with authorization and not authentication. Now, this can be confounding, and the spec itself and the way that we use OAuth kind of makes it worse, but let's just talk about that for a second. If I'm approaching the door, the room that's been assigned to me, I know the scope is right. I know the key's not expired. But if my arms are full with luggage and I hand that key off to my wife, she can open the door just as well as I can, because the door doesn't care who you are. It's just making sure that the key is valid, it's not expired, and that it belongs to that room, that it's the right room. So it's about authorization, not identity or authentication. Likewise, when you're interacting with APIs using access tokens, it's not doing any sort of validation that you are who you say you are. It doesn't care who you are. It's making sure that the key is valid, that it's not expired, and that the scope is correct. Now, we're going to come back to this because it's an area of confusion. But for the record, OAuth is about authorization. Now, Facebook and others have kind of misused OAuth for authentication. And it's one of the reasons that OpenID Connect was developed. OpenID Connect is a thin layer that rides on top of OAuth that specifically addresses those concerns of identity and authentication, and even provides a modern SSO alternative to SAML. But OpenID Connect is outside the scope of this presentation. See what I did there? All right. So we have the hotel analogy under our belt. Let's return to an app scenario. And if you notice, the kind of the layout of these two slides are the same. So we have these actors. They're similar to the actors that we saw in the hotel analogy, but they're doing different things. So we have an end user, we have Yelp, we have Google, and we have the Contacts API. The Contacts API is also owned by Google, but it kind of lives in a separate place as far as we know. It's got a different URL even, like interact with Google, say to authenticate, I go to accounts.google.com, and then there's this other property, contacts.google.com. So as an end user, I'm going to delegate access to Yelp. That is, I'm going to give Yelp permission to access my contacts on my behalf. And the way it does that is by obtaining an access token from Google, and then it uses that access token to interact with the contacts API. And all those things we just discussed, scope and expiration, apply here. So if the access token is expired, it's got some life on it, maybe an hour. If it's expired, the contacts API won't return my contacts. If Yelp is trying to write to my contacts or access my Google Drive or something, all of those operations will fail because the access token that it's using only has the scope of read-only access to contacts. Now, with all that under our belt, we can get into some of the formal terms that you'll come across with in OAuth. The third column here are those terms. You'll find these terms in the spec. And the first two columns are these two analogies that we just dealt with. So the resource owner, that is me sitting in front of my browser. The resource owner wants a client application to do something on their behalf. Like I want Yelp to go and access my contacts on my behalf. The client application in the example is Yelp. And this is not to be confused. If you're a front-end developer, you may hear client a lot in the context of browsers. Client application in this context just means the entity that needs an authorization, to interact with an API on behalf of a user. So this could be Yelp's Angular app. It could be running in your browser, but it could also be Yelp's .NET app running in their data center behind their firewall. The authorization server is the entity responsible for issuing these keys that we call access tokens. And then the resource server is the entity that has an API that the app can use if presented with a valid access token. So these four actors kind of do this little dance where I delegate authorization to Yelp. Yelp goes and gets a token. Yelp then uses that token to interact with the API. So there's kind of this little dance going around to make all this happen. So delegated authorization with OAuth. Now, instead of this form where I have to put in my username and password, what I'm saying is I trust Gmail. I kind of trust Yelp. I want Yelp to have read-only access to my contacts. And so now I have this friendly connect with Google button instead of that form where I have to put in my username and password. And this kicks off an interaction. I referred to it in the hotel analogy. It's kind of like a flow. I book a room. I show up at the hotel. I go and present some ID. I get back a key. That's kind of a flow. And in the world of OAuth, there are a bunch of different flows for different types of interactions and different types of applications. Some of those flows are problematic, and that's what we're going to be looking at. Any questions up to this point? All right. So let's take a look at the implicit flow. The implicit flow, spoiler alert, is now deprecated. It was actually deprecated. The way that the specification mechanisms work, you may or may not be aware of this, is that you have a version release. OAuth 2.0 was released a number of years ago. But then over the course of time, we learned some things like this flow is problematic. And so while they're working on a new version of the specification, in the interim, they released something called a BCP, a best current practice. And if you're evaluating a vendor, you want to make sure that they're not only, at this point, you want to make sure that they're not only OAuth 2.0 compliant, you also want to make sure that they are in compliance with the best current practice as relates to OAuth 2.0. And the best current practice, this came out in 2018, February of 2018, I think, is don't use the implicit flow because it's problematic. And we have better alternatives now to replace the implicit flow. And OAuth 2.1 is going to remove the implicit flow altogether. So the implicit flow came out at a time when browsers were very limited. What we could do with browsers were very limited. And what service providers could do with OAuth was very limited. So this was the best we could do with browsers at the time. So let's see what the flow looks like, and then we'll get into why it's problematic. So imagine we have this Yelp Angular app. It's running in my browser. I click on the friendly connect with Google button, and this kicks off an interaction. It sends me over to Google to authenticate. And it has some of these elements like a redirect URI and a space separated list of scopes. Now it needs that redirect URI because I've just been redirected over to Google. Google needs to know where to redirect back to once this interaction is complete. Now here's kind of an early source of confusion with OAuth. And here I am looking at an authentication form. And I just told you that OAuth has nothing to do with authentication. It's all about authorization. Well, the reason we have this redirect flow is that it's assumed that you're going to identify yourself to the authorization server in some way, but OAuth just doesn't care about it. Now, the most common use is I get redirected over to this form and I put it in email address and password. The important thing here is that Yelp is never seeing that. And also it doesn't, as far as OAuth is concerned, it doesn't have to be this email and password. It could be one of the fancy new passwordless services like Okta has, where I don't even put in a username and password, or maybe I put my YubiKey in and acknowledge a push from the Okta Verify app or something. So there's a whole bunch of different ways. And similarly with hotels, you may have encountered, now you can check in through an app. And then my phone becomes the key. I don't even have to talk to a human being at reception. So it's a different way to identify yourself, and OAuth doesn't care. OAuth assumes that identification has happened, usually in the form of username and password, but it kind of happens out of band of OAuth. What happens next is we get back into the OAuth flow, and that is the consent form. We probably all encountered these consent forms in various forms with modern apps. If you're like my mom, you just click on yes, no matter what it says. Hopefully we're a little more discerning. And this is your opportunity as an end user, because OAuth puts the power back in your hands. This is your opportunity to see what Yelp is requesting and to give Yelp permission or not. This is another thing that can be a little confusing about OAuth, and that is a client application like Yelp over here. They can ask for whatever they want. They can ask to send email on my behalf. They can ask for read and write access to my Google Docs. They can ask for the permission to write to my contacts. They can ask for anything, but it's at this consent form that I'm going to say okay or not. So you always want to look at that list of things that's being presented. And it's, you know, as developers, we have code smells when things look a little off. It's kind of a security smell. If you see like a long list of permissions, that's, you know, you probably want to run away from that. Usually it's just one or two that's like, Yelp would like read-only access to your contacts. And then I say, yes, that's why I kicked this whole thing off in the first place. But the client application can ask for whatever it wants. So while you have the power to revoke it or to deny that access, the other edge of that sword is that you have to be responsible for saying yes or no here. Assuming I say yes, what happens at this point is the redirect URI that was passed in the beginning is used to go back to the Angular app and to redirect with an access token. So now the Angular app has an access token, and now that Angular app can interact with the Google Contacts API using that access token within the scope that it's been granted. So in our analogy, this Yelp Angular app could now go read my contacts list and then do something with it, spam all of my contacts. All right, now this is problematic, and there's a bunch of reasons why it's problematic. The primary reason that is problematic is that the access token passes through your browser's address bar. And anything that passes through your browser's address bar is kind of easily intercepted, looked at, manipulated. If you notice, most of these lines are solid, and it's only the last line that's dotted. What I'm distinguishing there between is what we call the front channel and the back channel. The front channel is anything that passes through your browser's address bar, and there's less control over that. It's easier to intercept that, mess around with that. The back channel is when an application communicates directly with a service. Usually what we're talking about is the difference between a get and a post. And we'll see in a minute why that's important. But the punchline here is that the back channel is more secure. Front channel is less secure. Now that you may say, well, what's the big deal if the access token passes through the address bar and gets intercepted? The problem comes in that in OAuth, because we're dealing with an authorization framework, because the API doesn't care who you are, the access token is referred to as a bearer token, kind of like bearer bonds. It means who's ever in possession of it can use it because your identity is not being verified. Other attributes of that token are being verified, like that it's not expired, that the scope is right, but who's using it, the API doesn't care about. So if I can intercept an access token, I can use it in a way that the end user didn't intend. So let's look at this in action. I wrote a browser extension called the Implicit Flow Detector. And what it does is it detects when the implicit flow is in use and alerts you to that fact. And then you can take action around that. And I gotta say, I gotta thank Medium, because being a responsible security professional, I notified Medium well over 2 years ago that they had this problem. And they haven't fixed it yet. So I get to keep demonstrating it. Thank you, Medium. But here now it gets a little tricky, because what I'm going to show you in a second is that Medium allows me to use Google to create an account and log into their site. And you might be tempted to say, well, this is really Google's problem. Why is Google allowing Medium to use OAuth with this deprecated flow? It's a little tricky. I would agree personally that Google should get rid of the implicit flow, but that would break thousands of developers' applications potentially. And technically the implicit flow is in the current latest version of the OAuth specification. So Google and others have kind of tried to thread this needle where they advise you not to use this flow anymore, but sometimes developers do anyway, and Medium is one of those. So me as a security professional, I kind of lay this at Medium's feet because there are alternatives. Google also provides the modern alternatives that we're going to look at in just a minute. So let's take a look. This, I know this is hard to see probably, but this little blue shield is the implicit flow detector. It's available on the Chrome Web Store and the Mozilla add-on store. But what I'm going to do here is I'm going to sign in. I'm going to sign in with Google. I've already authenticated to Google. I've already identified myself to Google. So this piece of it is kind of out of band of OAuth, but I'm going to choose from the number of logged in accounts I have. And then I get over to Medium. No muss, no fuss. It knows who I am. And you can see that the blue shield is now turned to red. Again, thank you, Medium. I'd have to find another example if they ever do fix this. And what I can see here is that an access token has been intercepted. Now, Google is using what we call an opaque access token. That means I can't extract I can't decode this token and get information out of it directly. But here's where the problem lies. What I'm going to do is I'm going to copy this access token. And I'm going to open up an incognito window. So, this is the time where I say nothing up my sleeves, no sessions. I'm not logged in anywhere. It's an incognito window. I'm going to use my little cheat sheet over here. And now I'm going to go to one of Google's public APIs. So Google APIs.com/OAuth2 v1. Let me make sure I'm getting this right. Token info access token equals, and now I'm going to paste in that token that I just copied. So again, incognito window, no session established. Oh, look at this. Just with the bearer token, the access token, I was able to get back some information. Now, it's not terrible. I can see the scopes associated with this token. And in the world of Google, because Google has such sprawling APIs, a sprawling set of APIs, everything from their ad engine to your contacts, all of Google's scopes are fully qualified URLs. Scopes can be anything. It's just that the authorization server has to understand the scope. I also have access to my email address. Well, some random person now has my email address. I didn't really want that, but maybe not so terrible, right? Let's switch this from token info to user info. This is another Google API. Now I have some more information. So now I can see my full name. I can see my gender. I can also see my profile picture, which I almost certainly didn't want to leak out to the public because this is me from 1991, right? So not egregious. And again, I can only use this token with the scope. So I still can't say delete contacts using this token, but we're leaking more and more information. So this is why it's bad for the access token to come through your browser's address bar, because it can be easily intercepted. If you look this implicit flow detector, it's open source. It's pretty vanilla JavaScript. It's really easy to grab stuff from the browser's address bar. So the short story here is if you get into OAuth and you're using a service or a library that insists that you use the implicit flow, there are better alternatives and you don't want to introduce that into your app. So let's talk about the different types of clients that you can have with OAuth, because this is going to lead us to see a better alternative to the implicit flow. So there's this notion of confidential clients and public clients. And it's pretty easy to distinguish between them. A confidential client is an application running on a server. More formally, it's an application that you have complete control over. It's running on a server in your data center behind your firewall. And importantly, it has the ability to keep strings secret, or we trust it more to keep strings secret. So there's no way, no easy way for me as a say part-time hacker to go and extract a secret from your .NET app running on your properly secured, Amazon EC2 instance with the firewall set up properly and all that. So again, I'm assuming that you've properly set up your server, because that's not what we're talking about here. Assuming it's properly set up, you're running a .NET app, that secret can be stored as an environment variable or somewhere in a database, and I'm not going to be able to get access to it. Public clients, on the other hand, is everything else. So your native desktop apps, your mobile apps, your web apps, those are less secure. If you are like Yelp and you have millions of users, some percentage of those users have compromised machines and Yelp has no control over that. So it's not safe to store secrets in, say, your JavaScript spa apps. And, we try to be clever as developers and it gets found out every time. So you don't want to do something clever like break up your secret, pepper it around the app, minify your app, and code it in some way. People figure out a way to extract it. Even with mobile binaries, you can do string searches, you can extract stuff out of them. So it's just not safe to store secrets in those environments. And it's one of the reasons that the implicit flow was originally created, because we're going to see the next flow we're going to look at involves a secret, and it just was never safe to have a fixed secret in a spa app. Now, this is usually an hour talk. I have 45 minutes, so we are going to have to burn through some of the demos a little quicker, but stay with me. We're going to look deeply at the authorization code flow, and that's meant for your server side, your confidential clients, like your .NET, your Java, your Node.js apps. And I'll give you a little spoiler alert. A variation of the authorization code flow allows us to secure our spa apps without using the implicit flow by having a dynamically generated secret rather than a fixed secret that is easy to extract. But let's look at the older, more formal authorization code flow meant for server-side apps. So we have very similar players, and we start out in the same way. We click on the friendly connect with Google button. We send, we're redirected over to Google. We still have this redirect URI. This still looks pretty similar. We get the consent form just like we did before. So far, so good. Assuming we say yes, here's where things get a little different. Now we're redirected back to Yelp, but we're redirected back not with an access token. We're redirected back with this thing called the authorization code. The authorization code can only be used once, and it has a very short time to live. I used to work for Okta, so I kind of know these details. Okta's authorization codes, you have 30 seconds to use them before you have to start the flow over from the beginning. So that's already a benefit over an access token. Now, importantly, this authorization code is passing through your browser's address bar. So it could be intercepted by, say, a browser extension or malicious code. So put a pin in that. We're going to see in just a minute why that's not a problem compared to the access token. Here's what happens next. Let's say Yelps.net app has now received this authorization code. This is the way that redirects work. So Google redirected to Yelp through my browser. The authorization code passes through my browser's address bar, but finds its way over to Yelp. So now Yelp has its hot little hands on this authorization code on its .NET application running in its data center protected by its firewall. What happens next is that Yelp makes a back channel call. So from Yelp's .NET server to Google's authorization server, a request is being made, and that request includes a secret that was issued to Yelp by Google. Google validates the secret, it validates the authorization code, and now returns an access token to Yelp. All of this is happening outside of your browser. This never even touches your browser. Your browser never even is aware of this interaction. This is a connection between Yelp in their data center behind their firewall to Google in Google's data center behind Google's firewall. So this back channel communication is much safer. And I said before, we put a pin in that authorization code. So let's say I intercepted that authorization code. I'm a malicious browser extension. Well, there's nothing that I can do with it. I can't exchange that authorization code for an access token because a secret is required to do that. And I don't have that secret. Yelp's .NET server has been configured with that secret, but I don't have any access to that. So it's at that point that even though the authorization code passes through the browser's address bar, any attempt to use it is thwarted because I don't have the secret to use it. Any questions on that? All right, cool. So now that Yelp has its hot little hands on the access token, just like before, it can make a back channel connection to the Google Contacts API and go and grab my contacts. Now, this is great. This is super secure. It's kind of the flagship flow for OAuth. It's very secure, but it's not suitable for your spa apps because of this secret requirement. Now, there is a problem with this flagship flow, and I have a demonstration for it. We're going to go through it quickly in the interest of time. And if anybody's interested, I'd be happy to, show the actual demo out in the hall. I'm just going to go through it on slides here. But the short story is, while there is this vulnerability called the authorization code injection attack, it's really hard to pull off. It requires timing, it requires coordination. And we're going to see that the flow that remedies the problems with the implicit flow or enables us to use the authorization code flow in our spa apps, that variation on the authorization code flow also addresses this authorization code injection attack. So the punchline here, the global punchline, is that there is a proper way to use OAuth where you don't have the problems of the implicit flow or this authorization code injection attack. Let's take a look at it. We start out this authorization code injection attack with the same players that we've seen all along. Me sitting in front of my browser, the authorization server at Google, and a confidential client. And one thing I want to highlight here, I used PaperCall in my demo. I used PaperCall. It's important to point out that PaperCall has done nothing wrong. I'm just exploiting OAuth to make PaperCall do something it didn't intend to do. And the punchline here is I trick PaperCall into exchanging an authorization code for an access token that wasn't part of my original flow because I've stolen an authorization code. Now, I haven't compromised PaperCall. I don't have their secret. I just pass over an authorization code to paper call that it's able to validate is valid in exchange for an access token. Let's see how that works here. It's a little complex. I'm going to kind of go through it fast. In addition to these usual players, we have two other players. We have this centralized attack server. In my example, I just wrote a little Spring Boot application. And that centralized attack server is responsible for receiving stolen authorization codes and sending those stolen authorization codes to the attacker. And that's our fifth player, the attacker's computer. Both the attacker and the target user, the person I call the Rube in this scenario, they both have browser extensions that help coordinate all this. So first requirement is that you've tricked somebody into installing a malicious browser extension. What happens is that the target user, our Rube, goes to do the authorization code flow as normal with paper call. But because they have this malicious browser extension, when that authorization code comes back to them through the redirect, it's intercepted and sent to the attack server. And because authorization codes can only be used once, that redirect is interrupted. So that authorization code never finds its way over to Google. The next piece is that the attacker initiates a legitimate OAuth interaction as well. But when paper call redirects, rather than completing the flow with the authorization code that the attacker assigned, the attacker goes and peels off that authorization code from the attack server and sends that over to paper call instead. Now, at this point, paper call is just doing what it's supposed to do. It's received an authorization code. It redirects that over to, or rather it exchanges that with Google using its secret. And now it gets back an access token. But the access token that it gets back is the one that was intended for our Rube over here. But that access token is now sent back to the attacker's computer. And now the attacker can use that access token. Now that's a little, not completely understandable. I'm happy to go into it in more detail and even show you this little demo that I have. I have it all set up here, but we have our hacker and our Rube. But in the interest of time, I need to press on so that we can get to the main event here, which is the authorization code plus PKCE. PKCE. So PKCE stands for Proof Key for Code Exchange. PKCE, it's kind of fondly pronounced Pixie, like the little fairy or something. And what we're looking at here is a sequence diagram. If you've never seen one of these before, they're super handy because they show you interactions between actors going from left to right and top to bottom. And you can see over time how these different actors interact. So just like before, we have our resource owner, our client app, and our authorization server. And this is going to behave almost exactly the same as the authorization code flow with a slight variation. So let's just say that I'm interacting with the Yelp Angular app. And I go to kick off this flow so that it can access contacts on my behalf. Now, what happens here, the first difference is that it's going to create these two values. It's going to create a random value called V, and it's going to hash that random value that I'm referring to as $. Now, this happens in the app, inside the code logic of the app. And when I'm redirected over to the authorization server, that redirect is going to include the hashed value. So the hash value is passing through your browser's address bar. It can be intercepted, but by virtue of the way that hashing works, we don't have to care because they're called one-way hashes. It's not practical to get to the original random value V with today's computing power. It's not practical to reverse it, so we call them one-way hashes. So it doesn't really matter if it passes through the address bar and gets intercepted. There's no way for a hacker to get to this important random value called V. And the random value V is our stand-in for a fixed secret. It's a dynamic secret. We're going to see how that becomes useful in just a moment. So now the authorization server stores the hashed value for later. And at this point, we're in the normal authorization code flow. I get back the login form, I authenticate, assuming my authentication is correct, it's going to redirect back with an authorization code, just like we saw. So far, this is all regular. The authorization code passes through my browser's address bar. Just like we saw before, it doesn't matter if it's intercepted because the attacker doesn't have the secret. Well, what's the secret? The secret is this random value V, and this is passed as a post to the authorization server. So this random value V never passes through the browser's address bar. Now, this is a simple matter of the authorization server validating this random value V, which is our stand-in for a fixed secret. How does it do that? It uses the same hashing function, and it compares it to the hashed value $ that it stored way back up here. So it takes that random value V, it SHA-256 hashes it, and it compares it, kind of like the way modern identity systems deal with passwords, right? They should never be storing the wrong password. When you authenticate, it takes your password, it hashes it, and it compares it to the hash in the database. That's an oversimplification, but that's kind of what's going on. So if it's able to validate this random value V by using the hashed value it got earlier, now it can safely return the access token to the Angular app, and neither the secret, the random value V, nor the access token ever passed through your browser's address bar. It was part of a post request and response. And so this makes it more secure to be able to do OAuth in the browser. Now, still, if you have a malicious browser extension, there are still ways that this could be problematic, but it's more secure than the implicit flow by a lot. So I know we're at time. If you need to go, no problem, but I'll wrap up here with a quick demonstration of this. This is also an open source project. It's included with the QR code at the end. It's called the Pixie CLI. So this is a little Node.js app that's emulating, say, a native client, a native application, which again is one of those public clients, can't be trusted with a fixed secret. And the first thing it does is generate this random value V, and then it hashes that random value, and it base64 URL encodes it because the result of a hash is a binary value. We want to be able to send it through the public web. And it composes this authorized URL, which includes the code challenge method, which is SHA-256, and the code challenge itself, which is that hashed value. It's going to open up a browser, and I'm going to go and log in here, hopefully quickly. Let's see if I can find it. I have too many Okta accounts. Bear with me a sec. Michah, Okta.com. There we go. This is the one I care about right here. All right. Okay. I also need two-factor authentication. That's not right. There we go. All right. So the native client has now intercepted the authorization code, which it's supposed to do. That's a good thing. And now it's going to use the original random value V, which is referred to as the code verifier, to make a post to exchange that authorization code for an access token. That's this big, long, ugly, gnarly string. Maybe you recognize as a JWT. That's a whole different talk. And then just to prove that it's a valid access token, it uses this well-known user info endpoint to get more information about me. So that's Pixie in a nutshell. Very quickly, I know. Apologies for that. Sneak is awesome. You should go check them out. I usually say a little something more here because they sent me here, but we're at time. There's your QR code. Thank you for your time and attention. Sorry we had to burn through that last bit really quick, but I'm here for questions if you have any. Thanks a lot.